Okay, so two different statements will be logically equivalent if they have the same truth table values, exactly the same. Okay, and so we use logical equivalence. We make like a glorified equal sign. So I want the result from this to have the same truth table values as the result from this. So I need to show all of the combinations. So let's start with the P's and the Q. So P, true, true, false, false, true, false, true, false. Okay, so the if and only if, remember, they have to be the same. If true, then true, yes. If true, then false, no. False, then true, no. If false, then false, yeah. That works. Okay, so this is all called the left-hand side, right? So I'm going to be comparing that after I can create all of this. Okay, so let's start with if P, then Q. So remember, this is the one, if I show up, then I get the job. If I show up, then I get the job. If I show up, I don't get the job. Nope. If I don't show up, I get the job. Oh yeah, that's vacuously true. And if I don't show up and I don't get the job, that's vacuously true also. All right, so let's go to if Q, then P. Okay, so if I show up, then I get the job. Yes. If I don't show up, I get the job. Yeah, Dad, Uncle's owns the business, right? If I show up and I don't get the job, that's false. And if I don't show up and I don't get the job, that's vacuously true. Okay, so now I need to make a column where I take if P, then Q, and if Q, then P. Okay, so that means they both have to be true in order to be true. True and true, yes. False and true, nope. True and false, nope. True and true, yes. Okay, so we're comparing these two columns. So this is the right side. Do they have identical truth table values? Yes. So that means that therefore, so get used to this word, logically equivalent. Okay, so this is, just get another piece of paper out so you can write down these De Morgan's laws, because I need you to know them, and I want you to prove the logical equivalence, right? Show that the truth table values will be the same for both of these. Okay, so let's just, these would be a great test question since we don't have quizzes, right? Okay, so let's do the true, true, false, false, true, false, true, false. Okay, so the P and Q, let's just start with that in there. So that means they both have to be true in order for this to be true. So there's only one case that that's happening. Okay, so let's take the negation of that right now. So the negation, that would be false and a whole bunch of trues. Okay, so now let's do these two. So this is the one side, right? That's the left-hand side. So now let's make a column of not P. So not P is false, false, true, true. And then make a column of not Q. So that would be false, true, false, true. Okay, so now we're going to make a column of not P or not Q. So that means if one of them is true, then you get true. Okay, nope, no trues. Is one of them true? Yes. Is one of them true? Yes. Is one of them true? Yes. Okay, so is this, right? Make sure I erase this here a little bit. Okay. So what I need to know is this is the left side. Is it logically equivalent to the right side? This is the left side. This is the right side. Yes. Logically equivalent. So when you're proving that, you need to identify in some way, yes, that these are the two columns I'm looking at so that you can prove a logical equivalence. Okay. So I'm going to leave you to do this next one. I think you can do it. They are logically equivalent.